of vertical multiplication in its typical way, moving from right to left as we multiply across. In this example, we hope to illustrate what's actually going on here in terms of place value, which can account for what might otherwise seem like an arbitrary shifting of values that are found in the problem. Typically, we will begin by multiplying 6 times 5, whose product is 30, writing down the 0 in the ones column and carrying the 3 to a place above the 4. Next, we will multiply 6 times 4, whose product is 24. Adding the carried 3 gives us a value of 27. Now, it should be clear that what's actually going on here is not in fact 6 times 4, but actually 6 times 40, as the 4 in 45 is composed of 4 tens. Thus, the value of this is actually 240, which accounts for finding a value of 270 here when we add the 3 carried tens to this process. When we write 270, we're designating the place value for the problem, and other ones must line up with the 0, tens must line up with the 7, and other hundreds values must line up with the 2. Next, we'll multiply 5 times 5, whose product is 25, writing down the 5 and carrying the 2. Again, it should be clear here that we're not actually multiplying 5 times 5, but instead 50 times 5, whose product is actually 250. The appearance of this 250 will become clear as we further progress through the problem. Next, we'll multiply 5 times 4, whose product is 20, which we'll add here to the two carried hundreds, giving us a value of 2,250. And finally, it should be obvious by this point that it's not actually 5 times 4 that we're doing, but instead 50 times 40. And as students should know from multiplying by 10, the product of this is actually 2,000. Thus, adding our 2 carried hundreds to the 2,000 gives us a value of 2,200, with the 50 that we found from multiplying the 50 times 5 in 250. Finally, we'll add the products in each column, which have been lined up with correct place value. Here we can see that students should be familiar with the basic carrying during addition, but we'll later talk about what's actually going on with carrying during multiplication and alternative strategies students may be able to use if they would prefer not to carry. Thus, we can see that the final answer, 2,250, has been achieved by carrying during the typical vertical multiplication problem and lining up with correct place value. So what's actually going on in the problem we just finished? Well, it's easy to see that what we actually did in the vertical multiplication of 45 and 56 was simply applying the distributive property. It's easy to see this if we write out this problem in a horizontal way, showing 45 times 56, which in reality can be broken up in many different ways. But for example, we can break this into 40 plus 5, which simply decomposes 45, times 50, as well as 40 plus 5 times 6. We should be able to see that this is the same as 40 times 50 plus 5 times 50 plus 40 times 6 plus 5 times 6. Multiplying all these out individually will give us 2,000 plus 250 plus 240 plus 30. And we should be able to see that applying the distributive property here gives us, in fact, the same values that we added during the carrying method of vertical multiplication. We can see that these two terms are essentially what's represented here, and these two over here, giving us the same final product of 2,520. And as I said in the beginning, these numbers can be broken up in any arbitrary way. So just to illustrate that, this could likewise be shown as 56 times 45 being the same as 50 plus 6 times 40, decomposing the 56, plus 50 plus 6 times 5. In the same way as above, we can see that this is essentially 40 times 50 plus 6 times 40 plus 50 times 5 plus 6 times 5. Now all of these will be the same as we found above, just simply in a different order based on how we choose to decompose, which will again give us values of 2,000 plus 240 plus 250 plus 30. Again, this will give us the final value of 2,520, which we can also see is composed in the vertical multiplication method as well.